I am Mark Paluch. I'm the project lead of the Spring Data project, and we are going to talk today about event-driven Java applications by leveraging Redis Streams. So what is Redis Streams? So Redis Streams is a quite new feature in Redis itself. Redis, if you might know it, is a data structure server that provides functionality to manage lists, sets, key values, maps, all these kind of things. And the most recent version, which is the 5.0 release, ships with a data structure called streams. And streams are a log-like data structure that allows us to put in all sorts of data in an append-only fashion and then consume that data from our applications. So what is this good for? So one use case is messaging. If you are looking for a persistent way to communicate messages, so not just drop it and if you don't listen, you lose it, but rather in a fashion that you want to retain the message across a certain period of time. Activity tracking, so things like something happened and you're trying to log it and to keep it because some sort of business event has happened and you want to react with your application to that. You can use streams for metrics and logging to accumulate the data, put it into Redis because Redis it is a blazing fast server, and then consume it as you have the capacity. You can use it also like a commit log. So you have captured some state in your application. You want to emit an event that something has happened, something like an order was placed in your e-business system, and you want to track that. Or you can use streams for things like stream processing, so that you have a continuous stream of incoming data, and you're using the stream just as an intermediate storage that allows you to process that data and do something about that. Now, what's the outline of a stream itself? So a stream is identified with a key. That's a thing in the gray box. My stream currently is named events. So the stream itself is a container for multiple items. So you have this events and a stream skeleton, and into that stream you are able to put in multiple messages or multiple notifications. And one of these messages consists always of an identifier and a table of key value tuples. So in this example, I have some numeric identifier, -0. We will talk about later what this 0 is all about. And then we have a body that transports the actual value. And if you are familiar with Kafka, you probably might know Kafka body is something which is a binary representation and you have to take care about serialization yourself. And Redis Streams compares to that in the way that the body has already a structure with key value tuples. Still, this is all binary, so you could have some sort of serialization format in there, but this is one of the things that is different between Redis Streams and things like Kafka. Now, the identifier of a message in a stream is mostly derived from the machine and the timestamp where you insert the data. And if two processes hit the very exact same millisecond on the machine, then Redis needs some mechanism to distinguish these messages. So therefore we have this -0, -1. So this is basically a counter if you had hit the very same millisecond if you are inserting that data itself. One of the characteristics of a Redis stream is it is an append-only data structure. So you put in data and it is always appended to the end. There's a small asterisk to that because Redis is mostly about in-memory data. They also allow modification of these streams so that you can also truncate and delete a stream to a certain size. So while it is append only, you have some degree of maintenance freedom with Redis Streams. The body, as already mentioned, is a hash-like data structure. So it is really more a table of key value tuples. You could have the name property twice, and you would be able to have the first name is something, and the second name tuple is something else. But it's easier to think about this like a Java hash map, right? And there is a neat functionality if you want to consume a Redis stream, which is consumer groups. And why this is important, we will get to that in a minute itself. Now, how do you operate a stream? Redis has the notion of having commands that allow you interaction with particular data structures. So you have a command to add the data, to read the stream, to introspect that, to get information out of that. Redis typically prefixes all command groups with some data type specific identifier. And for Redis streams, it is the X. So therefore you see the X add command to add items. The X read command to read from the stream. X length will give you the length. And there are a couple of more commands. And we will take a look how this feels and looks like now in a demo. Cool. So let's take the Redis CLI. Font size is okay? Hope so. Cool. Now, I'm connected to my Redis instance. In my key space, I don't have any key whatsoever. So let's create a stream. And I'm creating a stream with x_add, telling basically the name of the stream, which is my stream. Put an asterisk in here. Don't worry about that. I will come to that in a minute. And then I'm continue basically with my key value tuples, which is value equals hello SpringOne. Right? Now, the result of that activity is two things. The first one is I'm getting this identifier, which is the message ID. And the second one is that Redis has created now this my stream entry here, which is a key of type stream. So we see it is this one. To consume that stream, I'm using the xread command and adding streams, my stream, and then the position from which I want to read that stream. So basically I'm saying xread streams, then specify the key of the stream I want to consume and the offset within that stream. And I'm having only a single value in that stream, so I'm getting the message that I already put in. We see the message ID, we see the body here, and everything is cool. Now, streams have this idea of not querying it once, but continuously, so reading all the time. So to do that, what I have to do is basically issue yet another command, take the last message ID that I have seen, and then run the command again. Now I don't get any data at all because nobody produced in that millisecond where I run that command any message. I can, however, block for a couple of seconds if I want to use reading in a blocking fashion. So let's specify 5 seconds. Nobody is acting basically on the stream, so this command then times out. But the general idea is that I'm polling on the stream. And this is one of the characteristics you have to account for if you want to use Redis streams, that you have constantly use polling as the mean to consume that stream. And either you are polling with blocking or without blocking. This mostly depends on your resource usage and your usage pattern, how many Redis connections you can afford, and these kind of things. So you have also seen this asterisk here, which I added for the x_add command. And this is reserved for the usage of replication. So you can use Redis either in a standalone scenario, where you have a single node, or with replication. And to not generate a new message ID when replicating these messages, the Redis replication protocol basically uses the message ID to pre-populate the ID itself. And this is the way how the stream gets replicated to another machine. Let's do this really quickly and add a message with a specified ID. So you see I'm entering this with 4 times 9 and getting the same message ID back. Read from the stream, and since this number was bigger than the previous one, I'm already seeing also this entry within that stream. So that's in general how streams work. Now, to build an application on top of Redis Streams, you probably do not want to use the CLI itself, but rather you would like to use a Redis client, probably from within your code. And there are 2 Redis clients. One is the Redis client, the other one is the Lettuce client. I'm also maintaining the Lettuce client, so that was the obvious choice why I choose that for a demo. So let's spin real quickly a Redis client in here to produce items on a stream. And what we do here is we create a Redis client connected to localhost, and then we obtain the command interface for the stream commands. The client itself exposes all the commands in the same way that you have methods which follow the naming structure given by Redis itself. So we have the x_add command. We put in here the name of the stream. And then we would have to fill in the body. And the body itself is a map. So let's get this set up, which is a map of string to string. And let's give it a singleton map. Value. And here we have then hello world. So we take that map, put it into our x_add command. Probably we should also print what we get in return. And then we are producing messages using a Redis client to our machine. So since the last message ID was bigger than the current time, then Redis starts using and adopting this 4 times 9 pattern and incrementing the last number. And if we consume from the stream, then we see, hey, we have already something in here which already works. So this is a simple producer which produces one value at a time. But I think it would be nicer to put that into a loop and do a while true loop and create a lot of these messages. Let's use the current date as something which is changing across these messages. So we can then go over to a consumer and build something that consumes these messages in a automated fashion using this mentioned polling pattern. Local date time is always my friend. Put it as a string in here, and to reduce load, we reduce the speed at which and the rate at which this thing is running to roughly 1 second. Let's put it that way. Run it, and then we are producing once in a while a message. Okay, this can run now. Let's go over to our consumer. To consume streams, we again need a Redis client. Let's take this one. And we can consume the stream with the x_read command. Right? So what we have to specify here is a stream offset, where we basically say this is the name of my stream, and this is the offset I want to read from. So this is the very beginning, 0-0 is the first one, and then we will get a number of rows or messages returned. Let's do this really quick, and then we see, okay, there is something happening, hello SpringOne, okay, cool. And now my program is exiting because I'm reading only once. What my stream-based application probably would like to do is poll on that stream for as long as the application is active. So we need a couple of things here, and that's something which shows really the complexity of Redis itself, because we have to poll on it, we have to remember the very last message ID that we have seen, and then take that and poll again. So while this isn't exactly fun, let's do that exercise. So we have to remember the last message ID. Let's take it 0, 0. Let's do a while loop here. You see, I fell already in love with while loops. Now, we put in the last seen message ID here, which will be on the first iteration 0, 0, and then we will count from there on. Okay. And then, yeah, let's print these folks out here. Then we will see the message, and we have also to update the last seen message ID, because that's the indicator for the next polling cycle. Right. So this would be a very simple, not really robust, but very simple client to consume the messages. Let's run this. So we will see first a lot of data, but then we are seeing constant updates that the timestamp is constantly updating in intervals of roughly 1 second. And believe it or not, this bit of code is the most error-prone thing that I have probably ever written. And why is this? So this process could break, so we could lose the connection to the server. The application could crash, we are currently running. And what about the state? See, we have consumed the stream up to a certain message ID, and we need to keep track of that. So what do we do with that? Do we store it in Redis, which could get killed, and all the data could get lost? Do we store it in a SQL database? Do we store it locally? Do we store it in a file? Well, this is exactly where this progress characteristic of Redis Streams comes into play. So in this current mode, I would have to take care of this reading progress myself. And I'm pretty much lost with that, because this is yet another thing I probably didn't know upfront when I thought about using Redis Streams. But now I have to deal with that to make Redis Streams more robust and more resilient, so that it survives a server restart and all these kinds of things. So in order to address that problem, Redis ships with this so-known consumer groups. So besides this hull of events and messages within a stream, there is something which is called a consumer group, or multiple of these. And what consumer groups basically do is they reflect the parsing state, the reading state, on the server side. So you can read from a Redis stream, let Redis streams know that you are part of a particular consumer group, which is identified by a name, and then Redis is going to store this reading progress on the server side, and this is taking care for yourself. So, and you don't need really to do much for that, except for identifying which consumer you are. So therefore you would go with this last consumed stream offset. And this is an indicator for Redis to basically use that consumer group. And additionally to that, you have to tell Redis which consumer group you are. And this is, well, consumer groups to set up is sort of terribly complex. So because you have to create that stream, you have to create the consumer groups, you have to register for that. However, it is possible and it is doable, but you need a little bit more setup for that. Now, there's a little bit more to that for consumer groups. Because when you consume a message, then Redis can either auto-acknowledge that message for you and treat that, okay, you have seen it, you have processed it probably correctly, or you can tell Redis when reading from the consumer group to not auto-acknowledge, but rather once you have processed that message, you issue the exec command, which means acknowledge that message, and then you won't see the message on the next iteration, and this allows you on progressing across the stream. So let's get you involved a little bit. So let's start a little stream processing experiment. I hope everybody of you has his mobile or laptop or iPad or at least something that can go to the internet and you're connected. Because what I want to do now is live stream processing of a little bit of data. So I've built a tiny front end, which is a Redis feature poll. So you have 3 options, select one of them to submit votes. That's a general idea. You can go to the following bit.ly URL, which is https://bit.ly/redis-streams. And then you will see basically the front end and the UI I have showed to you. And feel free to already play with that, submit votes. And in a minute, we will have a look on what this affects on the Redis stream side and how we can basically consume that data. So I'm still connected to the very same Redis server, and to start my Redis stream processing application, I need to start a boot application that basically does all the stream processing. Don't delete the data. That would be counterproductive since you already have started your voting. Now, what we see here is that we are getting a lot of inbound messages. So these are the messages that you are currently producing. So there is object-backed record, vote message with zpop, streams, and so on and so on. So these are the messages which are currently streaming in. And they are streaming into the feature poll stream, which is, so let's get the length out of it to see how many votes we have. 287, yeah, you're keeping that thing busy, that's good, cool. So we have that inbound messages that stream into our feature poll Redis stream. And what we are doing with a little bit of help of Spring Data is that we are listening to that particular stream. So we are providing with Spring Data Redis a facility that is called a stream receiver. So you set up a stream receiver, tell it from where to consume the data. So basically that's a stream offset for my feature poll. And then I'm subscribing to it to consume the records that are posted to the stream. And internally, I'm incrementing a sorted set, which basically means I'm doing stream map reduce here. So I'm taking the options that you've taken and incrementing the value in the poll stats data structure. So let's see where we currently are. That range poll stats 0, -1 with scores. And this shows us, okay, there has been a null pointer exception, probably. But the most votes currently have the streams features, followed with lolvote. And if we run that command multiple times, we see that these figures are updating. And this is a pretty neat use case, how to do stream processing and reduce your data to something which is essential to your use case. And my use case was to entertain you. So all the things that you have seen now are available in Spring Data Redis 2.2, which ships within the release train of Spring Data Moore, and it was released a couple of days ago. So this is all GA, and you can already use it. The code is on GitHub, And the link to that repository is GitHub mp911e, which is my handle, and Redis Stream demo. So you can go and fork it and clone it and play yourself with that code. They will find the complete example with the barebone Redis client. You will find an example with Spring Data Redis itself. And probably this can help you to get your head wrapped around the Redis Streams feature to basically focus on your use case and help you to solve your requirements. And that being said, thanks a lot for attending.